Good afternoon, everyone. My name is Tanzila Zaman. Thank you all for joining me today as I do my internship presentation. So the way this presentation is going to go about, I'll just give a little bit of background about the organization that I worked at for my internship. And then after that, I'll give you a brief overview of my project for my internship. And then past that, you'll have opportunity to ask questions. And there are abstracts in front of you, so take a look at it. And so you can also jot down points if you have any questions. And I also have food in the back, so feel free to enjoy. So this past summer, I had the opportunity to work at RTI International. If many of you don't know about it, it's a research organization that's not only based in US, but in multiple other countries as well. They focus in a lot of different variety of different processes, but one of their major thing is working with wearable device and working with new technology to help improve health outcome. And they RTI International, they give students an opportunity to intern with them over the summer. For the most part, it's an unpaid internship, but it'll only last 2.5 months long. So these are some timelines that I've listed here. It was roughly about 2 months to 2.5 months long, and students have the option to extend it if they would like. Some of the deliverables were basically we had to do a poster presentation for the showcase at RTI, and I had to write a research brief, which is right now currently under review at RTI Press. And the other thing we had to do is have weekly meeting with Dr. Ferberg, whom I did the internship with, and his team. And also we had to attend twice a week lunch talks where people from different domains of RTI researchers came in and spoke about their research. And the other thing we had to do weekly was RTI-wide mandatory workshop on professional development for interns, which is about 4 to 5 hours long, where they taught us how to write grants, how to do proposals, and also the other things like how to apply for jobs and tailor your resume. So that's just a brief overview of RTI. The place where I worked at, it's called Digital Health Informatics Department with Dr. Ferberg and his team. And a lot of my project was based on wearable devices and technology, which Dr. Ferberg and his team specialize in. So now that we know a little bit about RTI International, let's just dive right into my project, which was an analysis of heart rate variability using an open source software. Just some fun facts about wearable devices. As of 2019, one of the study predicts that 2 out of 3 adults have at least one wearable device that they own. And if you see on the graph on your left, most of that number is from people ages between 25 to 34 years old. And I also fall in that category. And one of the main reasons why people actually like to have wearable devices is because of the biofeedback they receive. And the biofeedback could be anything from steps that were taken, heart rate measurement, or calories that were burned. And those biofeedbacks have been thoroughly used now by researchers and clinicians all across the state in the United States and also outside of the US to improve health outcomes. And one of the most common biofeedback that is present, even if you check your cell phone, you'll find is heart rate. And that's what my project was based on. So these were the objectives that I was trying to accomplish, is to generate a heart rate data set using a validated wearable device. The reason why I emphasized on this one is because only one of my search, I found that only 5% of all the wearable devices that are out there has been actually validated and FDA approved, meaning that only 5% of those you can use for your research or for any type of clinical trial that you're doing. So that was something we kind of emphasized on. The second one of my objective was to analyze this data set using a validated heart rate variability software, interpret the result, and finally provide recommendation for future study. Because my part was just a little piece in a puzzle, 10,000 piece puzzle, I would say, at RTI, because Dr. Ferberg, what they're trying to do is based on this method, they're trying to do a bigger study in the future, which I'll talk about in a few minutes. These were the phases of my project, exploring what HRV means, data generation, literature reviews, result from the analysis, and conclusion and limitation. And we will go through it one at a time. So the first phase of my project was just understanding heart rate variability, because I knew what it meant, but I just didn't know if it was even useful to anyone in general when I first started out. So I'll just start off with basic things. I'm pretty sure a lot of you are from clinical background, so you know that in our body, there is something called an autonomic nervous system, which is divided into sympathetic nervous system and parasympathetic nervous system. Those two together helps to create a homeostasis in your body, basically maintains a balance. So the way I look at it is brake and gas in your car. Don't want to be always pressing the brake, or you don't want to be always accelerating. You want to have a balance in your body, and that's what it helps to do. And many of the organs in our body are influenced or are dominated by this system. And one of those organs is the heart. So what is heart rate variability? What does it mean? What it means is basically when our heart beats from one beat to the next beat to the next, it's not continuous. There's a little bit of gap between beat to beat. So as a result, what happens is that gap is not same across all beats. There is a variation. So maybe from second to your third beat, third to fourth beat, those gaps are not the same. And that's what it's called, the heart rate variability. That's where this term generates. And I have a little bit of definition. Variation among successive heartbeats is defined as heart rate variability, which is exactly what it sounds like. And in this photo, R to R is basically your one beat to one beat. That's the different. That's the time we're looking at. Using this heart rate variability, why it's important. If you remember a few minutes ago, I just described that your heart was innervated by the autonomic nervous system, the gas and the accelerator. So if there is any type of abnormalities in your heart rate variability, that means there is some form of abnormalities is correlated, directly correlated to abnormalities in your autonomic nervous system. So once this phenomena was established, clinician and researcher has been doing research for the last couple of decades and found that it could be used as a pre-diagnostic tool for cardiac abnormalities, for treating asthma, GI disorder, psychological disorder. This was a little bit interesting to me because they were combining multiple different things under psychological disorder. When you're driving, there's a study that was done using heart rate variability. They could tell when you're feeling drowsy. So, which was very interesting because they were trying to find out causation or correlation between driving, drowsiness during driving, and HRV, and they were able to find that. So these were some of the things that HRV is used for, and one of the main things that it's used for is for performance enhancement across fitness trainers and a lot of sports personality. They use HRV on a daily basis to enhance their performance. So kind of a little bit about what HRV is, why we even care about this. The next phase of my project was to generate a heart rate data set. Now, a lot of people might ask the question, you just generate a data set, what's the big deal? If you remember, I just said only 5% of all the devices that's out there is validated. We could use for research purposes. So we had to find um, so, a device that we could use to generate long-term data set, and we had to do it without any breaks in between. So what I mean by that is basically traditionally, if you wanted to generate heart rate data set, you would have to go to a healthcare facility and then have electrodes stuck to your chest, and patient would be immobile for a certain period of time. And that's how you gather data. But nowadays, with invention of wearable devices like Apple Watch, this has become much more easier because you don't have to actually go to a facility and be there giving up your everyday work. You could just gather data from a wearable device. And the reason why it's even the reason why wearable device allows you to gather data is because there is something in the back of it. It's called a PPG sensor that reflects light based on when your blood flows in your body, and that's how it captures the data. So as I was doing my searches and trying to find out what wearable device that's out there that we could use for this research, I found out something called an E4 Empatica wristband that study has been done before to compare the data quality from this device and a traditional ECG lead, and they found out that 75% of the data quality was similar or the same. So we kind of decided we should go with E4 wristband, and the reason why we used a wristband is, again, we wanted to collect data continuously without any break, and also it allowed us to capture the data without having to save it at a third-party cloud server. And it was also readily available at RTI, so we didn't have to go through any approval to get it. And this is what it looks like. So when it's capturing the data, this light will be turned on, and that's how you know your data has been captured. So once we gathered data, so what we did was we had participants wear this wristband, and then we went to a gaming facility where we collected data for 2 hours. Once we got the data, the next step was to find out what software that's out there that we could use in a cost-effective way. So spent a lot of time doing this process. So I just wanted to show this word cloud. Some of the keywords that I used for my searches were HRV, biofeedback, software. And so these were like combination of keywords that I used to find my literature reviews. And so the process was basically when I found a paper that I thought was relevant, I read the title and I read the abstract. And then I was looking to make sure these 4 domains were covered in this paper or not. If it wasn't covered, then I would just move on to the next one. And some of the inclusion criteria, other things that were that I was looking at, the paper had to be published in a scientific journal, and it had to use something called a free software for analyzing data, and it had to be published to 2010 and beyond. So with all my literature search, I found out that these are the top 3 HRV software that's out there to analyze heart rate data set. And the second 2 right here, for those 2, if you look at under programming language, one has to be very proficient or very expert in either Python or R in order to use these 2 software. I started using R, but at one point I had to pay for getting the software, portion of the software, and our team didn't support that, so I had to move on from this one. And so afterwards, after thorough research, what we found that Cubios, which is the top one, had almost 6,000 papers that were written about it or used Kubios to do data analysis. And it's available for any user, and you don't have to be proficient at coding, so you can use it at any time. And so keeping all that in mind, we decided to analyze our data set using Kubios. And so the next portion of my research was to go ahead and analyze our data set using Kubios. And this is, once you enter the data into this software, this is what the result looks like, a typical result. You'll have your R2R, your B2B throughout this whole time. And then what you also have is this results right here, these 3 domains. So they have, and we'll go through each of them one at a time. So you have time, frequency, and nonlinear domain, which are the 3 focus of all of our project. So what happened was that when I was looking at the papers, a lot of the papers looked into time domain and frequency domain, but not a whole lot of paper looked into linear, nonlinear domain. It's still a vague line as to what all these parameters they kind of mean. So since I myself was learning at that point, I decided to skip this domain and just focus on the first 2. Now, time domain, what exactly these means? These are some statistical measurements or statistical analysis of your heart rate data set that just pops up. And as you can see, it gives you your maximum heart rate, minimum heart rate. It gives you your mean HRV value, so things like that. But the most important parameters that we were interested in looking at over here was the standard deviation and the root mean square. These 2 parameters are an indicators of parasympathetic activity, which is what, gas or the, because I'm trying to see if you guys are listening to me or not. Break. Yeah. Okay, so now good try. So that's basically your break of your body. So meaning that if these values are somewhere lower than the standard values, that means the brake system in your body is not working properly. There's something going on. So that's something that that as a researcher we are interested to look at. The other thing is that for our purposes, we weren't really focusing on this domain because, as you can see, it requires 24 hours of continuous heart rate data collection, which we weren't able to do because ours only had 2 hours of data collection. But I still wanted to just show that what all these parameters meant over here. For our purposes, the domain that we looked at is known as the frequency domain. The frequency domain, what it does is basically it's like an energy band that it gives you. It's like all the powers are clustered in different energy and frequency, and it just tells you in what frequency most of your beats or heartbeats are gathered in. The reason why it's even important, as you can see, again, there's a lot of parameters over here. This LF over HF ratio, that's the one that we're looking at when we're looking at this domain. If this ratio is lower than where it's supposed to be, that means your sympathetic or parasympathetic nervous system is activated. Your brake in your body is activated. If it's higher than where it's supposed to be, then your sympathetic nervous system is activated. Why am I even saying all these things? A lot of the time, researchers or clinicians, when they're trying to look at, when they're assessing a patient and when they're trying to find if their autonomic nervous system is working properly or not, sometimes they do tests like this, or they collect data set, heart rate data set, and analyze it and look at this ratio. It hasn't been concrete. There has not been concrete results that the physician or clinician would go based off of this number, but they might do some additional tests. But that's what we're trying to establish over here, that, hey, there is much an easier and much cost effective way of performing this type of test. And for this domain, again, you don't have to collect data for 24 hours long. Just on the side note, we found out that this ratio from the participant was higher than the standard value, which meant that that person was in a state of stress, meaning that their gas was, they were kind of accelerating. So as a result, we kind of hypothesized that because it was at a gaming facility and we knew that this person was in a stressful situation. So that was something we found. Next thing, so these were all the results from my analysis and everything. Now, going off on limitation, one of the biggest limitations for this study was availability of software. We were only allowed to get those wristbands only for a few hours. And if I had to get it for a longer period of time, I had to go through multiple departments, get approval, and that was all on me. But the project itself was only for 2.5 months so I didn't have that opportunity. So I had to work with what I have. My sample size was also very small, which is only 2, and we weren't able to collect data for 24 hours long. It would be interesting to see if we could analyze the same data set using those other 2 software that required Python and R. And also, there weren't any study that was done previously that had standard values for a 2-hour-long data set. So the standard value we were comparing was from 24-hour-long studies. If I had to go and provide recommendation, I would say at least get a sample size minimum of 30, which is, I know it's too much to ask for at RTI, but according to central limit theorem, if you want to capture the average from the population, you should at least have a sample size of 30. I would also like to compare and the contrast data from different wearable device, just not E4, perhaps Apple Watch, if that's possible, if Apple would let us use their data set, and also use other software to analyze the data. In conclusion, so like I said, this was just a little piece of a bigger puzzle. Dr. Ferberg and his team are looking at similar study in law enforcement officers where they have 2 officers wearing this wristband for 3 months now, and they're trying to publish data from that. So when I came into the project, he said, I'm doing the similar type of study, but it's been going on for 2-3 months. Can you see if it's even feasible or if it's even possible to do a study that would be for a shorter time, like 2-3 hours? So that's what I was trying to establish over here. And so through this, I learned that, yes, it is possible. But again, there hasn't been any standard value that was established before. So we may need more participants to find the standard value first and then compare it. But I did learn a few things as what HRV is and what it's used for. Learned that Kuvios is basically one of the most used software that's out there. And also learn about the matrices in HRV and analysis of HRV, why it's important, and gathered data and analyzed it myself. And the result that showed the dominance of sympathetic nervous system, which we kind of hypothesized. And the last thing that I learned from this internship is that working at a really big company like RTI, there are definitely a lot of places you can ask for help, but it's solely on you. You are extremely independent. You're working everything by yourself. On those meetings that we had with Dr. Ferberg and his team, it was all yes and no answers. There wasn't any like open-ended question, nothing like that. So you have to be very independent. You have to be motivated enough to work for that 2.5 months and have to be very disciplined. So that's something, a takeaway that I had from this internship. And that was it. These are my references. And I want to thank Dr. Furberg and his team at RTI for their help. I also want to thank Dr. Sif. Thank you very much for all your support throughout the program and everything you have taught me. Thank you very, very much. Dr. Townsend, if you're listening, thank you very much. Mariel, thank you. Big shout out to you. Really, thank you for all the help that you have done, that you have given me throughout this program. Lindsay, thanks. And Kelly, thank you as well. And last but not the least, to all my friends and my professor and my supervisor, plus my family, thank you for being here today. I really appreciate it. I hope you enjoyed. And yeah, thank you very, very much. Questions?
I have a question. Is it the LF and HF value?
Yeah.
Or, so you were talking about if it's above the standard or below the standard. How is that standard set?
So the standard is from papers that were published before. The paper that I looked at had a total of 800 participants, and that's where they collected the standard from. So they broke it up into different groups, and I can show you the standards. So these were the standard values that I gathered from that paper. So I was just going based off of that.
Yeah. And those are based off of 24-hour studies.
Yes,
right?
exactly. Yeah. Yes.
Just out of curiosity, the papers that you looked at, did they just look at men versus women, a certain age group, or?
So the one that I decided to focus on, so they did their study twice, one in 2015, one in 2016. 2015, they had only 500 participants. In 2016, they increased it to 800. As far as, so they broke it down in age. Let me show you. So that's how they broke it down, 20 to 30, 30 to 40, and male, and then that's how they got the ratios from that or the results.
I know that you said you were thinking about having an increased sample size. So what would you do if you were to do the study again, and what kind of outcomes do you want?
So there is a lab in RTI. It's the virtual reality lab. So what they are trying to do is basically replicate the same experiment, but they want to do it with at least 5 people. What they were trying to see is they were going to focus on basically the LF over HF value, and they want to see whether, so this value, they are going to look at in a way so that in the stressful situation, this value would be higher than what it's expected. And in a normal situation with the same participant, it'd be lower. They're resting and digesting and not stressed. So that's how one of the ways they're trying to look for. And if I had to redo it between 30 people, I would probably find the same thing, that this value is higher than the standard value.
So I want to clarify something before I ask the question.
Sure.
But I'm looking at your abstract here, and it says that they were respondents during an escape room challenge, and you mentioned it was 2 hours.
Yeah.
So was it all 2 hours that were a stressful scenario?
Yes.
Then? So do you know why the decision was made to have 2 hours in a stressful setting versus 1 hour low stress, 1 hour high stress?
So the way this was set up, it was like few of us that went there. So we didn't get the chance to like break it up into, first of all, it's less stressful, then it's more stressful. We were given 2 hour block in that room. So I mean, I didn't know how else to like break it up.
That's right. I was
That'd be interesting to see. And that's what they were trying to establish right now at the.
When you mentioned he's using police officers, I kind of figured.
Right. Exactly. Yeah. Okay. Hope I answered that.
I don't have a question, but having been at a lot of different conferences over the last 6 months, presenting our other research, one of the sessions that I was presenting at there was also a bunch of representatives from Lockheed Martin who are doing a whole bunch of wearable data collection research. They're, I don't know, maybe everyone already knows this, but they have gathered so much data on all sorts of different kinds of wearables and stuff like that they don't even know how to start analyzing it. So they're like doing open source and opening up to everybody to kind of like dig in. And I was thinking that if you were interested in seeing if there was ways of accessing and being a part of that all of you all, I mean, it would be pretty amazing.
That'd be amazing, absolutely. It's just there is a lot of open source software that's out there, even for HRV, but not many studies has been done on it. That's the problem. Like there are software that's out there, but nobody has done studies on it, so nobody knows how valid that software is. So it would be interesting to see with those data set what we can do.
Yeah, a lot of what they're doing is like taking airplane drivers through all sorts of different scenarios and virtual reality training things and stuff. So they're having a lot of different, and then they're all hooked up to all sorts of things. So it just be like lots and lots and lots of data to dig into.
Yeah, absolutely. Interesting.
I'm just curious to know your experience with videos. Did you learn MATLAB?
It was a very easy software. You just download it in your laptop and put the data set through the software, and it just pops up that result that I showed you earlier. This result, it just does it all by itself. So you don't really have to be any proficient coder, because I did use our HRV, which we needed to pay for a little amount for using that software, but Dr. Ferber didn't want anything that we have to pay or anything. He wanted something that anyone can use without knowing any form of programming language. So, sure.
I'm just curious, when you were collecting the data, so what kind of setting was it? Like, there were 2 participants, but
it's just a gating room, and that's where we wore that wristband in Vatica, and it just keeps on, once you wear it, once it's strapped onto your arm, it starts collecting data set. And after that 2-hour block, we took it off, and then using a USB plug, so I plugged it in my computer and got the data. Yeah, it was an escape room. Yes, Dr. Galvin.
Applications out to patients and consumers.
Right.
So, police and pilots, but general population down the road, you see applications for this?
Would be nice, yeah. So a lot, like I said, a lot of the clinicians, they don't even know anything about HRV. I work at the infectious disease department. I did the same presentation to them as well. And they were their mind was blown completely that this is even out there for us to use. So I would think gathering data especially for someone who has cardiac abnormalities would be interesting, and just finding out those results rather than having to do those stress tests would be one way we could implement it. And it would be cost effective as well.
EKG kinds of things.
Yes.
So this would sort of like advance it or take it to another level?
Yes, exactly, yeah. This would definitely take it to another level. Less stressful, but more
the
cost
data right there.
Yes, absolutely. Any other questions?
I have one more.
Okay, sure.
Being a psychologist, I like what you talked about in terms of the psychological
Disorders, yeah.
disorders. Were there other ones? Like
so
sleepiness doesn't really.
Yeah, the reason why I brought it up is because that's not really a psychological disorder, but they were categorizing it under psychological disorder. The other thing in inmates, there has been a lot, like suicide is it's a common thing in inmates. So one study looked at inmates and gathering data from them and using that data to predict suicide rate in inmates. There are lots and lots of study that's out there. Yes.
Their questions are maybe for something else. When you were looking at the literature, did you see anything comparing wearables like this where you're wearing it around the clock versus like what you were talking about, the phone EKGs where you just check?
So the one that's the phone EKG ones, those haven't really been validated right now. To my knowledge, it may have changed, but I didn't find anything like that yet.
I'm just curious because if I think about EKGs on your phone where you have to choose when you're going to check.
Right.
Versus something that's constantly
constantly.
data.
Yeah.
I feel like the person wearing it could experience a different source of stress because they're constantly now aware of data being collected.
Yeah.
It's something
that is true. That's true. I agree. Haven't found any, but that's something.
I was curious if anything came up.
So does this find the same, like, what does this find that, what does the wristband find that EKG does? Or is it just more portable?
It's more portable. It's more portable form of data. EKG finds the similar thing, but with EKG, like the LEDs that I showed you earlier, there are EKG bands that you can wear around your chest, but it's less hassle to wear something on your wrist versus on your chest. So with this type of band, it's easier to gain data. So that's basically it.
And it's just as accurate.
It is, yeah. So that's what I was in one of the slides. The EKG, the data set that you get from an ECG lead versus the wearable device like Empatica E4, the data quality is 70%, 75% same. So. Any other questions? Thank you again to all for being here. Really appreciate it on a Friday afternoon.